Hello, my name is Robert Brenneman. I'm here with Sarah Vivian and Samantha Moore. Today, we did our lit review on the analysis of the impact of vibrations on circuit boards and vibration dampening methods. We broke our presentation into 5 different sections: a little bit about circuit boards, how we analyze the effect of vibrations on printed circuit boards, impacted areas of the boards, dampening methods, and some studies we thought were useful. Why are circuit boards important? Printed circuit boards are the backbone of electronic devices that function as a mechanical attachment point for components and supply a path for electrical connection. Why are vibration-resistant circuit boards important? Vibrations can cause components and connections between components to fail, resulting in a faulty electrical system. So in order to study the impact of vibrations on PCBs, mode shapes of the PCBs must be studied. Modes of vibration are specific patterns of oscillatory motion, and they give shape to the vibration. These modes are defined by the characteristic, frequency, and boundary conditions. So across our study, we found that there were 3 parts to each vibration experiments that we studied. They all had some way to simulate the vibrations, measure the effects, and analyze the data.
The areas that are impacted from the vibration loads are the solder joints, connectors, and large components. The large components impact the mode shape more than the smaller ones, as you can see by the circled component's mode in the picture next to it. The connectors on inductors also undergo stress and can experience failure under vibration loading. We also read a study discussing placement on the PCB and how it impacts the failure of certain components, and those pictures are on the right of the screen. One study focused on solder joints, analyzed the mode shape in the solder joints, which is on the left of the screen, and then looking at the stress analysis of solder joints in the bottom right image, you can see the stress is concentrated on the edges, and this introduces the concern of crack propagation and making sure the joints can withstand the conditions they will experience in the field.
One of the main reasons why we study the impacts of vibrations on circuit boards is so that we can develop methods for reducing and damping the vibrations. Some of the main methods we studied were reinforced ribs, which add structural integrity to the board, wedge lock clamping, which you can see in the right bottom corner. With this type of clamping, the board is clamped or held along the entire side versus just the corners, minimizing the response to vibrations. Board on board, where instead of having one thicker board, you have 2 smaller ones with a separating medium in between. This minimizes the deflection and displacement caused by the vibrations. Then you have underfill, where you place epoxy on the connections, so not all of the stress is placed on the solder, minimizing the vibrational impacts on the solder joints. Another method is particle dampers, which are small capsules that contain many small tungsten balls inside and are placed at the center of the boards. In the dampers, the particles absorb the vibrational kinetic energy and dissipate it into heat through frictional effects and collisions between the particles, as well as between the cavity walls and the particles. Here's a short video demonstrating the particle damper. Obviously, you can see that the board without the particle damper experiences more displacement than the one with the damper.
This study we read exemplifies the process of vibration and analysis. In it, the authors compared vibration motion using contact-based versus contactless measurement methods. The contact-based measurement was done with an accelerometer, and the contactless measurement was done with a laser Doppler vibrometer. Accelerometers are a popular choice due to their affordable price and simple setup. However, the authors found through their tests that the weight of the accelerometer causes it to underestimate the axial stress of the solder joints, and it can influence the vibration motion, which you can see in the bottom right image. This drawback of accelerometers leads to the exploration of other more accurate measurement techniques, especially for smaller PCB constructions. A laser Doppler vibrometer, or LDV, is contactless, so there is no added mass to the system, and it's a more realistic measurement. However, the complex installation setup of an LDV could deter researchers from using that measurement method. The authors determined that when the weight of the accelerometer could be neglected, the measurements from the LDV and the accelerometer were within 1% of each other. So for a heavier PCB construction, the accelerometer measurement method would be preferred.
This study really emphasized what we really wanted to demonstrate throughout our whole presentation was the importance of the process of conducting a vibrations experiment. This was our analysis of the impact of vibrations on circuit boards and vibration dampening methods.